started the recording.
Thank you, Kiran. Sorry.
Yeah, no problem. No, thanks for reminding. Okay. So quick agenda for this 2 days, today, tomorrow. I have divided into 3 sessions. The goal is today we will complete one full session here, introduction to the software testing, to the bug life cycle, and also some of the topics in the session 2. So that, and then tomorrow again, we will start from the middle of the session 2 and complete till end of the session 3. So the total major goal is today, tomorrow, we will purely concentrate on manual testing. And then from the next next few weeks, then we will focus more on automation, performance, the other aspects of the testing. So basically, we will also prepare from ISTQB point of view. We will also prepare everywhere from interview aspects, like how do you, once we talk about a topic, what kind of interview questions you might get on the topic that we covered. So we will talk from that aspects as well on each of these during these sessions. Any questions? Okay.
I think we are good. So.
Sorry, I missed that.
No, we are good.
No, we are good. Yeah, go ahead, brother. Yeah, I mean, some of the team members, they have little children. You know, you might hear some background music once in a while. That's fine.
No problem.
Yeah, go ahead, please.
So, starting, we are taking all these sessions thinking that no one knows anything about software testing. So we are going from the ground zero, and slowly we will build upon one topic, on topic to topic. We will build upon the intensity or the complexity of the topics. So that's how we designed this. So let's start with testing, manual testing. So not only manual testing, let's talk about like what do we need before we start learning about testing? What are all the aspects that a tester should have? Basically, there are 3 things: people, process, and technology. When we talk about people, the traits of good software tester is, one thing is they should first and foremost is their curiosity, their their ability, or always want to learn something new, and they have to question if they don't understand something. They have to come and question what is that requirement about, till you understand the requirements fully. That's where you have to have a good analytical skills. So basically, how you get a good analytical skills is basically you have to be curious. If somebody tells what is that requirement, you have to think or visualize that requirement in your mind and see how an end user is going to interact or how to use. Basically, you have to be in the shoes of the end user. So that's where you need to think of all different kinds of scenarios. Like if somebody says develop a shopping cart, you have to think of what are all the positive scenarios to test that shopping cart, or what are all the negative scenarios to test that shopping cart. Giving a invalid credit card, or giving a invalid CVV number. So these are all, you have to be thinking of different kinds of ways of basically you have to analyze or visualize those requirements. That's where analytical skills, curiosity, and questioning, all those are like interrelated, and that's a foremost skill for any good software tester. And then you have to be patient, and also give attention to the detail when you're doing the actual testing. So you don't get like bugs unless until some bad software developer developed that. Normally you don't get bugs that easily when you're testing. So you have to be patient. You have to give attention to the details. You have to make sure when you're writing test cases, you have to think of all kinds of different scenarios, and not only whatever scenarios you wrote before. While you're doing testing, you have to do some exploratory testing, and that's where uh, patience and attention to detail. Where this is also a very important skill. When you find a bug during your testing, you have to document that bug. So attention to detail is very important. The way you document the bug, so that anyone who sees that bug should be able to easily reproduce that. Like if you find a bug, the way you communicate that bug to your team, is also very important. So you have to mention all the details of the bug, how to reproduce the bug, so that the developers or anyone who is fixing the bug can reproduce that easily. So that's where the second important skill, attention to details and patience, is very important. And then the C is also reporting skills. That's where again we discussed reporting. The way you report or the way you communicate to the team is also very, very important. Communication in a team, especially for testers, is very, very important aspect, people aspect, to excel in your career. And also timing. So you have to, if you find some bug, so if you find a bug today morning, and you have to immediately, based on the severity of the bug, you have to think that, okay, this bug is very, very critical bug. Immediately you have to stop whatever you're doing. Maybe you have to first you report that bug and then continue whatever you're doing. So there are some bugs which are very critical bugs that needs to be immediately brought attention to the team. So that's where, like, if you're doing testing, if you find some bug, if you say if that bug is very, very critical for the product to be developed, to be rolled out, without that product cannot be rolled out, then that is something very, very important. We have to immediately bring that particular bug, the kind of importance that it needs to be given. We have to immediately provide that or give that, escalate it to the upper management or development team. So it's very, very important to do. So the timing, when you should be very clear when you have to communicate. If you're not getting required, if you don't get a build, so it will affect your whole testing time. So you'll not be able to complete your executing all your test cases if the build doesn't come on time. So if the build doesn't come on time, you have to communicate again. You should not sit idle or till if something is missing some timeline, you have to again communicate appropriately immediately to your manager or a lead or development or project manager. So timing is also important. So these are the 4 important traits, and all these are part of communication skills. And analytical skills is one kind of a your communication trait. All these are like, communication is very, very important for a tester. And even so uh, uh, without this, even if you know whole process, if you know technology, if you don't have these kind of traits, it is difficult to excel in testing. So these are some of the things which, when you are doing, when anybody is interviewing you, they look into this. Like, they constantly see how you are communicating, how confident you are, how you are talking. Will you able to? They judge in that 1.5 hour of the interview. They judge these things, like, will you be able to? How curious you are during that interview. How is your communication skills? Will you be able to communicate confidently to a developer? So that's very, very important. So people not only just see whether you know this technology, you know this process, but they also see, because when you find a bug, you have to confidently tell this is a bug, this needs to be fixed. So you have to confidently talk to a developer. Developers will have a tendency of saying that, oh, this is not a bug, this is okay to be there. So if we, so they, you as a tester, we have to be confident when we are telling, okay, this is a bug, this has to be fixed. Without this, we cannot certify the product. So that's where people, while interviewing, they will also validate how confident you are. Will you be able to talk confidently in the team? So when you have team meetings, you have to ask questions. So will you be able to ask? You should not be, people also judge you that, okay, will she or he asks questions in a meetings, or if you have any doubts, will you just keep it to yourself, or will you be vocal about what you want, or whatever you don't understand. So these are all very important traits for a tester. So just keep working on these communication skills when you are training for interview, or when you're on the job. This is a constant learning for you. You have to be very up to date on these, especially on these four traits to excel in your job. Then comes the process. Once you have these skills, the next is how well you understood the process of software testing. Software testing is more about the process. There's a terminology. You have to understand these terminologies of V model. What is, how actually the whole software development life cycle works. In that software development life cycle, where does the testing life cycle fits in? What is the bug life cycle? When you find a bug, how it progresses, how when you find a bug, what you have to do, and how do you, once it get fixed, what you have to do again. And there are different types of testing types, and different, like black box testing, white box testing, sanity testing, smoke testing. So you should be able to be aware of all these testing types. You have to know at what type, when you have to implement which technique of testing. So all these things you need to be aware of, and also what are all the different artifacts during the each life cycle of the testing. So each life cycle, when you are doing requirements and analysis, you have to produce one kind of artifact. When you are designing, you have to produce a test cases. That's one artifact. Your test plan is one artifact. So when you have to produce what artifact is also a very important thing. And nowadays, everyone are using agile process and Scrum. So you need to understand what is an agile, what is a waterfall, how Scrum fits into the agile. So those are all the some of the things which we should be aware of as part of process. Knowing the process helps you, gives you the confidence of what is, how software testing is being implemented in a bigger companies, and also how software testing is implemented in software development lifecycle. While somebody is building a product, when we have to enter as a software tester, when we have to start testing, when we have to end testing. So all those things, it will give you a good understanding, knowing the process. Just knowing the process doesn't suffice. There is also few technologies, you have to query some database, you have to write some SQL query, or sometimes you might work on, not just always work on Windows, sometimes you might need to work on Unix. So that's sometimes you need to understand some Unix commands, like opening a file in a Unix is a little different than opening a file in a Windows system. So you need to understand that. And most important thing is you need to have at least one automation tool knowledge and one programming language knowledge. So whenever you work on one automation tool, obviously you have to do some kind of a programming. So one automation tool and one programming language goes hand in hand. So you need to know at least one automation tool like Selenium or Cypress or any tool. If you know one tool, it is easy to, any other tools are very similar to, all automation tools are very similar to each other. So if you are well versed in one tool, you can easily work on other tools. Same, if you well versed in Java, you can easily work on C#, you can easily work on Python. If you're on, to some extent, you can easily work on JavaScript. So if you're well versed in one programming language, one automation tool, you can easily apply that knowledge to different types of tools or different types of programming language. So these are all the three important aspects combined, not only software testing. If you take a development also has people, process, and technology aspect, but that will have a different types of process or different types of technologies. But when you take about software testing, these are the three important aspects in each area. These are the important aspects that we have to cover. Yeah. Any doubts, keep asking doubts. If you have, then and there, stop me. If you have any questions, don't wait till end of the session. So we will miss the context by end of the session. So if you have any doubts, just ask me.
Yeah, I have a question, Kiran.
Yeah.
So under people, we've discussed about reporting skills, right? So for example, if we found that there's a problem or a bug, so do we report it as a documentation or is it verbally during a team meeting?
Yeah, that's a good question. Usha, right? We will talk about those artifacts, how we have to, when you find a bug, normally nowadays, everyone are most of the 90% of the companies are using Jira. So Jira is a bug track. Jira is used for most of the any project related documentation like requirements or test cases or your store. Nowadays, people are calling as stories. These are some requirements. They have a different name in Scrum. When people are following Scrum, they call it as stories. So they write whenever you find a bug, very previously when there is no Jira or no, if a company is very new, they don't have any tools. People used to communicate in Word documents. They have a template in a Word document to write to document a bug. People used to open a Word document all the things in the Word document, take a screenshot, put it in the Word document, and send it in a mail to the developer. That's the old way of doing things. Now everything has a tools. For every thing we have a tool in software industry. In every process of SDLC we have a tool. So, and Jira is a popular tool. So if somebody is starting new, just work on Jira. Just understand Jira is a very simple. We will cover as part of our, in tomorrow. I will show you, open some Jira and I will show you the Jira tool. So start with Jira. You don't need to. So there is something called Bugzilla or different ALM. Different tools are there, but don't worry of any other tools. If you're starting new, work on Jira. Just Jira. How you have. I will show you when we come to that particular topic how you open Jira and enter a bug in the Jira. So yeah, in the reporting, basically, yeah, you open a Jira, you have an option to enter a bug. You enter the details there, and Jira will tell where to and to whom you have to send this bug. So you enter your team developer's name, you assign that, and then he will start looking into the bug.
Okay, thank you.
Hi, Kiran. Can you give an example of a bug?
Yeah. Who is this?
Anbu.
Anbu. Yeah. So, for example, right? Take the shopping cart. when you add products to your shopping cart, and ideally when you enter your credit card details, click on submit. So when you click on submit, ideally what you expect, it has to say send some order to some database. The database has to record your order details. Some order ID has to be generated, and it should display telling that, hey, this is your order ID, and you will get this package in next 2 days or 3 days. That's the expected behavior, right? So, but when you click on submit, nothing happened. You got a blank screen, right? That's a bug. So that's what you have to report to the developer, saying that when you click on submit, if nothing happened, you got a blank screen, right? One thing what you will do, first you will go to a database. You developers will tell you, hey, if you click here, you have this table. In this table, this record has to be there. You will verify as a tester. You will have access to all the required infrastructure. So you will verify in the table. You did not see any new record in the table, and your system is screen is showing blank. That's a very big bug. And so if a record is there in the table, still system is showing, your UI is showing you a blank screen. That's also a bug, but the severity might be less. So these are the different types of bug in one scenario. When you're testing that particular scenario, you'll find these types of bugs.
Thank you, Kiran.
So as part of this session or this workshop, we will cover all the aspects. Like we will in the next today, tomorrow, we will purely focus on process. And there is no specific things on the people traits. It is something that you have to acquire by yourself. But I will give you some techniques like what is important, how you have to acquire analytical, how to practice getting analytical skills, how to, when you are attending calls, when you are attending some meetings, you have to show that you're interested in that meeting, or you have to ask questions in the meeting. So that's very, very important. So I will give you some tips and tricks on this people aspect, but there is no specific, we will not cover it as a topics, but we have today, tomorrow, we will mostly focus on process. And next three weekends, we will cover mostly on the technology side. So one weekend, today, tomorrow, we will fully focus on process. And when we're talking, we'll talk about ISTQB. All these are ISTQB topics as well. So if you're very well aware of this process, you can also give an attempt for ISTQB certification. It's not mandatory again, but it is good to have.
Good morning, Kiran. This is Prashanti. I have a question. Regarding the technology that you mentioned, SQL, Unix automation and all. So do you suggest any particular preparation before attending our training? Like, do you suggest like some websites where we can go and do some prerequisite kind of study?
Yeah, definitely. I will suggest, but it is optional for you to prepare and come, because we will cover everything from the ground zero. So it is optional for you to prepare and come, but it is good that if you have the time and if you can do some preparation before the hand, it is always good to come with some prepared some knowledge to the class. Yeah, definitely. I will give you and I will share some how do you do SQL testing. I will share some notes, some tools. Like you need not even install SQL on your machine. There are some online. You can go open a browser and do some have a virtual SQL and work on that. Same with Unix. So I will give you some tips and techniques like how easily you can get started on SQL, Unix, and automation. Automation we are covering in depth in our course, but SQL and Unix I will give you some tips, and I will guide you on how to learn. These are some of the easy topics. We need not spend a lot of time on this. But yeah, I will guide you on how do we do on SQL and Unix. But we have in-depth sessions on one programming language and one automation. And yeah, before you start on these sessions, I will send you the some prerequisites. Good to prepare.
Hey Kiran, this is Jerusha. In technology, what is the difference between SQL and programming language, please?
Yeah, that's a very good question. So both are similar. Both are not very similar, but when I say SQL, it involves database. So programming language is a code that you write to execute or give a computer some instruction, right? So if you have to give some instruction to a computer to do some task, you write some program so that the program will be executed and the system will be converted into some machine language, and the computer understands that and executes the task. That's the programming, the basic aim of the programming language or the code. But whereas SQL is a database. So you have data. So most of the times as a tester, you work a lot with the data. So apart from automation or any writing code, you mostly testers work a lot with data. So when I say data, the data sits mostly in some kind of a database. Now again, there are two types of databases, SQL and NoSQL databases, but we will go into those when we in the technical sessions. But think of a database. So when somebody and you entering some going to Amazon, I will take in this whole sessions, I will take an online like Amazon as one reference. So I will keep quoting Amazon, some scenarios in Amazon, so that you can relate to that. So whenever you go to Amazon, you create your profile for the first time. You give your address, you give your name, username, or your username, password, everything. So this will be stored in some database in Amazon data centers, right? And that will be stored in some of the database. So this database can be any kind of database, Microsoft SQL Server or Postgres. There are different types of databases there. So it will be stored in the database. So as a tester, we have to retrieve the data from the database and see whether the data is correctly being stored in the database. That's where you write some SQL queries. You query a database, right? So that is where the SQL comes into picture. And that is how the SQL is different. You write select star from this table. That's you'll have some table names in the database. So in the table, you have this data, actual data sitting as a row in the table. So when you query the table, whatever you see, that's where you have to write some SQL queries. So writing a SQL query is different from writing a code. And the code operates on when you write some code, it gives some instruction to a computer. Whereas when you write a SQL query, it just gives you it gives an instruction to your database, and it retrieves a record from the database, or it works on you update something on a database, so it will modify something in a table. So that's where SQL and programming language is different.
Thank you, Kiran.
Hi, Karan, this is Soumya. So, writing a programming language, any kind of language, so we can easily connect our SQL with that in order to fetch the data from the database.
Sorry, I didn't get the question.
Like, I don't know, but I'm just curious to know. For example, we are writing any programming in the Java code, and in that code, it is possible to include this SQL programming also.
Oh,
like
got it. Yeah. That's a very good question. So that's more of a developer. You're asking from a developer's perspective, right? So yeah, definitely there are two ways of interacting with a database. you can interact with a database outside the code. That is, you install some SQL server on your machine. It will give you a client. So from that client, you open the client, write some queries, and interact with a database. The second way of interaction with the database is via code. For example, you're writing a Java program. In your Java program, you can write a code, and in that Java program, you can also put some SQL query in your Java program, so that that SQL query will be executed through a program.
Yeah. So it is possible. Yeah.
That's how actually the coding works. So in order to do that, there is different kinds of tools available in Java or in any programming language. We have there is something, a concept called uh, o- there is
ODBC, Oracle database connectivities and
Exactly.
Java database connectivities.
Exactly. Thanks for helping me there. Yeah, ODBC. ODBC connectors are something, ODBC are some of the connectors that are available in Java, which will help to connect any kind of database using your program. And then using that, you can write some code and execute some SQL code on using some programming language.
Okay, so like why this question come into my mind, like because for example, if we go shopping on Amazon, if we are existing customers, so maybe that entry, whatever we are entering, it's going to some database and maybe verifying it happens, right?
Correct.
That's how we are writing the program and all.
Correct,
So,
exactly. There will be some, if we talk more at a detailed
okay.
level, there will be some code component. There will be some component in the code, registration component. That registration component will have some code. That registration component will have this SQL server or the SQL to verify whether the record exists or not, or if the record doesn't exist, then enter that record, or if the username is already taken, through a message. So verifying whether the username is already there, they might execute some SQL query through the code. And once if the query has some result, then they will say, oh, this is already there, so you cannot use the same username again.
Thank you so much. I really like the session so far. Thank you so much.
Yeah, keep asking the questions. There is no hard and fast rule that we have to cover all these in the stipulated amount of time. Even if you're not able to cover all these, we can have some extra sessions as well. But keep asking questions, get your doubts clarified then and there. And if you're good on the topic, only then only we will move to the next. There is no hurry thing where we need to complete this by end of this thing. So yeah, just keep asking questions. So far, very good questions.
So one last thing, this World 3 School is a good website to go and practice on this SQL, and I think it should be same, right, for automation.
Yes, yeah, W schools, right? Wow.
W3 school. Yeah.
W3 school.
Yeah, W3 schools. Yeah, that's a good thing. But but tomorrow I will give you more some of the tools for SQL Unix. But
Sure.
yeah, but let's not focus right now into technology. Today, tomorrow, let's more focus on process. And when we are starting the technology sessions from the next week, then we can focus more on SQL Unix. But yeah, today, tomorrow, we will mostly focus on process, and let's get the process fully, so that will help during a STLC, and during a process, when you are executing some process, you have to interact with the technology. Like while you're doing testing, you have to, while you're doing functional testing, that's a process. You have to use a tool called Jira, or you have to use a tool called SQL. You might also use a tool, you might also use Unix. So that's where technology comes in a process. So as a part of a process, technology comes, and it will help technology helps improving a process. So let's first understand the process, and we have a very detailed workshops for technology. So during that time, we will focus more on that time.
Thank you, Kiran. Thank you for keeping us on track.
No.
So Kiran, going by Soumya's question, so is it just the developer who does the coding, like executing the SQL through the programming language, or the tester also have to do it?
From the coding point of view, there are different types of, like, if you are purely a tester, who is your responsibility is only to test, then you code for automation. You write some automation scripts to automate some of the test cases that you execute manually. That's where the coding comes into picture there. In some companies, they have a full stack developers, where currently where I am working, I'm also coding as well as doing testing. So I will be writing two types of codes. One is I code something from a requirement. So I see what is the requirement. Based on that requirement, I do a coding on for the actual product. And also once I complete my coding, I write unit tests. So that's also another kind of a programming or coding to test the particular unit of what I code. I also do a unit test. So that's one type of coding. The other type of coding is once I complete everything, end of the sprint, I also write an Cypress automation script. So that's a different type of coding. I use a different tool called Cypress. I go to that tool and do some coding in there. So, and for development, I do a coding in Eclipse. I go to Eclipse and write some Java code. And again, I go to a different tool, Cypress, and write some Cypress code there. So based on the scenario where you are doing, your coding differs. So yeah, ultimately you will be doing some kind of a coding. But if you're purely manual tester, you might not go into that. But nowadays, nobody is completely purely manual testers. Most of the companies, there are like 80% in any scenario, in a basic scenario, 80% you will be doing manual testing. At least 20% you would be doing some kind of a automation testing. Even worst case, even if you're not doing any automation testing, automation scripts, you might be even executing your automation scripts somebody has developed.
Right, thank you.
Yeah, Kiran, excuse me.
No problem.
Sushma here.
Okay.
When you are talking about programming languages and the other tools, do we need window-based operating system or Macintosh or any iOS things? It's okay.
Yeah, both Windows and Macintosh. Anyone. If somebody has an Apple or MacBook, yeah, Windows and Mac are both same. So yeah, everyone in any company, only these two will be there. If you join a company, either they will give you a Windows machine or they give you a MacBook. So this is anyone would always suffice. So when you have Unix, when you have a requirement for Unix, normally softwares in a real time, Amazon, if you are working, these things will be installed on some Unix boxes. So if you ideally in 80%, you need not go and test at the Unix level. But if you are in some projects, you might be working on some ETL testing, or if you have to read some file, data will come in a file, and all the transactions at the end of the day, they might put in some file and put it in a Unix box. If you have to test that kind of a thing, that's where you need to connect to a Unix box via Windows machine. Normally what we do, we have a Windows machine. From the Windows machine, we install something called Netzilla or FileZilla, and we using that we connect to a Unix box, Unix server. So they give us a server name, Unix server name and password. So we give that username, Unix server name and the user details, and from Windows machine we connect to that Unix box, and then we work on that through via Windows machine or MacBook. So if one is sufficient. Either you need not have a Mac knowledge separately, or if you have Windows machine, that's well and good. You have everything to start off.
All right. Thank you, Kiran.
But not a Chromebook. Chromebooks won't. If you have a Chromebook, that won't be sufficient for our automation. You can't install any Java on a Chromebook, or you can't install Selenium on Chromebook.
Okay, but Macintosh is enough for this QA automation.
Yes, yes. Mac or any Windows, regular Windows with even Celeron, basic Windows Celeron machine also works. You can install something on your machine where, except Chromebooks, rest all any Windows operating system should work.
All right. Thank you very much.
Okay. Okay. So yeah, shall we move to the next topic? Next topic is software development lifecycle. Let's understand the how a software is developed. What is a life cycle for developing a product, right? So even first and foremost, there are two types of software development. Two types of projects. One is a in-house project or a product development, right? Or there are two types of companies out there. One is like Amazon. Amazon is a product development, whereas TCS, Infosys, these are all consultants where they don't have any products, right? TCS doesn't have any products, or Infosys doesn't have any products. They help the companies, other companies, to have, for example, I am a bank. I'm starting a bank. I am a bank, so I am very well versed in financial details, but I don't have a knowledge of software development. That's where I reach out to some companies like Infosys or TCS or any other companies to build a product for me, right? So I will go to I will put in my website in a bank. I'll put in my say that I need a product, this kind of a product. So companies will come and bid. Like I'll get a bid from TCS, I'll get a bid from Infosys. So they will say, okay, at a very high level, they will understand my product requirements, at a very high level requirements. They will understand these requirements, my domain, and they will say, okay, I can do this product in 3 years. Or somebody will say, I can do this product in 2 years with this much amount. Somebody will say, I can do this project in 3 years with this much amount. So that's how the bidding goes. So initially, the companies will bid for projects. Once they get that bid, then they start the software lifecycle or development lifecycle. That's one type of company. There are some other kind of companies where they only develop their own products. Like Amazon develops its own products, Walmart develops its own product. They don't go for they have in-house development teams. Right? Internally, that their projects, they will take some outsource few things to some other companies internally, but they manage their own products. So these are called product-based companies. There are some companies like CA. They build their own products and then they sell that products to all the other customers. Like ADP. If you take ADP, ADP has a product. That ADP product they sell to different companies like Amazon, Walmart, or whoever they have to run payrolls, right? So if I have to run a payroll, I will buy a ADP product. So ADP is a product-based company. So they have their own products. So I can't go to ADP and tell, hey, will you build a banking site for me? But they say that's not, they are a product-based company. They are not a company like TCS or Infosys, right? So we have to, when you're working in a first thing, when you're going for any interview, you have to think that what kind of company is that? Is it a product-based company, or is it a consultant company where they take projects from different companies? So that's very important. When you're attending an interview, you have to understand what kind of company is that. Based on that, you have to prepare because they will have a different kind of end of the day. It's all the development life cycle. If your development life cycle is same in both companies, but the way you operate, you have to go to a different client place. You have to go to a client place, and you might work at the client place, client location, or if you are a product-based company, you have your own office. You know all the business requirements will be coming from the same company. Whereas if you join a TCS, business requirements will come from a different company. So understanding that is very important. And so that's the pre context of before we start the development life cycle. That's the, if you are working on a consultant company, then you would be bidding for projects, whereas you don't need to bid for projects if you're working in a product-based company. So once you get a project bid, or once you're trying to start a project, the first thing is, before bidding, they understand at a very high level what is the domain, what is the what is the kind of a product they need, right? For that, the company will involve a project manager and to some extent some architects, and at a very high level they see, okay, they'll have some discussions and say, based on the previous experience, they will come up with some kind of estimations that we can for example, right, when I started my career in India, we have a startup company, and this startup company, they approached one healthcare. There is a healthcare project. They bidded for a healthcare project, and they said that project is about converting a client. They have a Windows application. They want to convert that Windows application to a web application. So this company went there. One of the project manager and one of the technical software architect, along with both of them, went to the client place. They understood that requirement at a very high level. They saw that client Windows application, how many screens are there, and they, based on the previous experience of developing a web application, they said, okay, we will develop this project in 6 months. We will complete converting this Windows application to a web application in 6 months, and this is the cost for it. Then somebody gave like a 1 year. Other company gave a estimation of 1 year. So obviously, then they said like, okay, they picked our company because we gave a small, 6 months time frame, and we're less cost than the other company. So that's how they got a project, and we start. That's where during that time the development life cycle has not started it. Came the then they formed a team, like a 20 members team, which has developers, testers, and then they started. Once they formed the team, they also have some business analysts in the team. Then this business analyst again went on site, collected all the detailed requirements. Then during that time, this is like a 15 years back. So during that time, we don't have this Jira. So they collected everything they created a big list of Word documents with all the requirements. During that requirements, normally who participates in requirement analysis? Ideally, the important participation is from the business analysts, right? So nowadays in Scrum, business analysts are also called as product owners. So the product owners will talk to the end customer who is giving the requirement. For example, if you take a healthcare system, so the healthcare system has a team who wants how their what kind of software product they want. So they went to the team, they met the particular healthcare system team with this product owner or the business analyst. So they talk to the team, they have some contacts from the team where they talk to this team and understand what kind of system they want. So they wrote all these things in the detailed analysis in the requirement documents. And then that requirement during that time, ideally the main important player in the requirements from the company side is business analyst or the product owner. But along with them, we will also have one system analyst or system architect, and also a software testing lead. Not every software tester will be involved during this time. If a software test a lead tester will also be part of the requirements. So while people are gathering the requirements and writing the requirements, he will also understand what the customer needs are. So this is a good opportunity for a tester, especially for the test leads, to understand what a customer wants, right? So in a very old-fashioned way, only business analyst is used to be part of the requirements, and business analyst used to tell the requirements to the tester. All right. So during that time, there is one classical software diagram is there. Like customer asks for a swing, and end of the day it will be developed in a different way, right? I will show us after. Maybe I'll pick something after that. So so previously that's where the good practice is to involve testers early in the phase. So to involve testers will be involved at requirement analysis phase itself, where they're collecting the requirements. So in interviews, people will ask, when have you started involving in the SDLC? When is your involvement? If somebody says I will be involved during testing phase, then that's not wrong. Testers will be involved in all the phases, not just the testing phase. That's a very, very important thing to note. There is always a misconception that if you're new to testing, they'll say, okay, testers will be involved during testing. No, testers will be involved during all the phases, but testers will have a different kind of a goal in each phase. The goal in requirement phase for a tester is to understand what customer is asking, right? And the goal of the testing phase is to check whether the developer has developed what customer asked, right? So there is for each and every phase, there is a different goal for a tester, but tester will be involved nowadays, especially there is in a company. If I have a software company, I will definitely make sure I have a good. If somebody is collecting a requirement from a customer, I will make sure I send my test lead. I'll send my architect along with my business analyst to collect the requirements, so that everyone will understand what customer wants, not just the business analyst. Business analyst will document the requirements properly. It's not the tester's job to document the requirements. Tester's job is to understand what the customer wants and verify whether the business analyst is documented correctly. So those things can be done by tester, but here the major role is played by the business analyst or product owner, and supporting role will be played by a tester. Whereas testing, in the testing phase, the major role is played by the tester, and maybe developers can play a supporting role, and supporting role can be played by product owners can clarify some some questions the testers have during the testing phase. So everybody will be involved in all the phases, but the level of involvement in each phase depends upon their role. Is that clear? Any doubts still here?
Kiran, actually, I share one message. I think you can explain through that where the test role comes. You're talking about one picture, right?
Yeah.
I think, is that the picture which I have sent you?
Oh, okay. Somebody, let me open that. You have a. Yeah, this is a picture. Yeah, thanks for sharing, Soumya.
No problem. Thank you.
Yeah. So as I said, right? So previously, this is a classic picture that is like a shading across the cars and IT industry as a joke. So people asks for it. The customer wants a swing. So this is what the customer explained it to a business analyst. But when the business analyst writes a requirement, he writes the requirement as this. And when the system analyst or the software architect comes into the picture, he understands this thing, right? He architects like this, and down the line when it goes to the developer builds something like this, and the end result of this is something like how the programmer wrote the code. So this might be the programmer wrote the code, but the customer might need this thing. See, what the customer really need is this, but the way he explained might be a different thing. He might be explained this thing, but that's where the other aspects of requirement collection comes into picture. The product owner has to correctly probe the customer what he wants. Customer might want something, but he might explain it in a different way that the business analyst might understand differently. So that's where if you just involve just business analyst, and if the business analyst tells something, so the way if you go from different levels, the information gets filtered. And if I say if a customer says 100 things here, by the time it goes to a tester, if the tester is not involved here, he might only understand that 30% of what customer wants. So that is where nowadays the best practice is to avoid these kind of situations. So they're involving the whole team. When I say whole team, not the whole, for example, as I said, 20 members, if 25-member team is formed, not all 25 members will be involved here. Important leads, all the leads from the different a developer, a development lead, a testing lead, along with the business owner or the product owner or business analyst will be part of the requirement, so that they get the first-hand information from the customer, and they can avoid these kind of situations while doing the development. Yeah, this is a very apt picture when we are discussing this requirement analysis. So that's how to avoid these kind of mistakes is, involving everyone, and everyone will get the first-hand information from the customer, and from then on, product architect will start designing the system based on that, and then testers will start testing based on what customer needs. So that's how the important this thing will come. And
Kiran, I have one doubt. Can I ask, please?
Sure, please go ahead.
Yeah. So during the meeting with the stakeholders, So you are saying like nowadays, it's not the old-fashioned way where one person used to get everything and then he passes the knowledge to the other person.
Right.
In the nowadays scenario, when they have the meeting with the stakeholders or any customer, so it comprises the team from the client side. It comprises the team of the business analyst or product owner, along with the system architects, along with the software tester, like one person office, so they can understand the requirement uh, easily.
Correct.
Is that right?
Yeah. That's the point I'm trying to make. Yeah.
Okay. Thank you so much. Thank you.
And as a tester, normally, again, coming to this aspect of curiosity, right? Here we talked about testers should have that curiosity. So we can ask any tester in the team can ask like, hey, can you also involve me when you're talking to customers? We keep asking that like to the product owners, like when you're talking to customers, can you also involve us? So sometimes product owners will say, if it is a critical thing which they don't want to disturb customers, they'll say, okay, we will involve it, whatever things we need. Or sometimes they will say, okay, I will involve you. They will send, there are some scenarios where they'll say, hey, I am meeting a customer during this time. This is the meeting code. Nowadays, everything is online, right? There is no face-to-face interactions. Mostly it will be on Zoom call. They will say, they'll send us a Zoom link. They'll tell that, hey, this is the Zoom link. I'm joining and talking to this customer during this time. You can join, but you can if you have time, you can join and listen to our conversation. So that kind of if you're really interested. Otherwise, there will be all mandatory attendees in that meeting, like test lead and all. But as a part of a testing team, you can also, if you have time, if you have the interest, you can also request telling that, hey, I want to be part of the customer interaction so that I can better understand the requirements. There's no wrong in asking that. And when you ask these kind of things, people will be very happy to know that, okay, you are curious, you are interested. Right? These are some of the things when you're really working in projects. These are some of the tips, like to make sure that to give you a positive outlook in your team. Yeah, you can ask these kind of questions to your team, in the meetings. So that's about the first part, requirement analysis. And in requirement analysis, what is the tools being used is Jira. So nowadays, people previously during like 10 years back or 15 years back, they write big documents. They used to write and put it in some servers so that everyone can access. But nowadays it's Jira. When somebody is writing it, when a business analyst or a product owner has some discussions with the customer, they convert those discussions into requirements. There are two types of requirements in Jira. One is called Epic. Epic is like at a feature. They will tell a customer wants this feature. Like shopping cart is a feature. So they'll say, I want a shopping cart feature. That's an Epic. In order to develop shopping cart, you need so many components. Like you need to integrate with a third-party payment systems, right? You need to integrate with a shipping system. So you need to implement. You have to talk to a database to fetch the customer details. Those are all the things. And what kind of details, what kind of customer details should we capture for the payment details, right? Those are all the requirements. So and this will be part of stories. When I say shopping cart is a feature, and it is also called as a Epic in Jira. Under that Epic, it will have multiple stories inside that Epic, right? And those are all again the sub requirements. So low level requirements for a high level requirement, right? So all these will be documented in Jira. So the outcome of this requirement analysis is zero user stories, or a very high level system design, or very high level features, right? Then once you have that high level requirements, so there is no mandatory rule that everything has to come out like fully at end. Like I can just say I want this feature, right? I want this feature with high level requirements, and then these high level requirements will go to the system design phase. That is where the architects comes into picture. So every project will have architect. Architects are some senior developers who are like well versed in development, like who's doing development for years. So as a developer, they go the next level for a developer is ideally an architect, becoming an architect. So if you take a developer roles, starting is you become a developer, then you become a dev lead, and the next level of dev lead is system architect. Now currently I'm acting as a dev lead. My next goal is to become a system architect. So like I have been developing from last 2.5 years. So maybe in next 5 years, my goal is to become a system architect, right? So that's how in a development, you have this kind of hierarchy. So once you have what a system architect does, he will tell, okay, you need a payment module, then what kind of components you have to use. There might be 10 to 20 different kinds of third-party tools might be available to communicate to a payment system. Like to communicate to Visa. If somebody enters a Visa card, I have to communicate to a Visa company. So, and send these details to the Visa company. So in order to do that, there might be already so many systems or so many plugins available. So now I have 20 different plugins. Now I will choose, as a system architect, I have to choose what is the correct component and how to develop the component. Then I will have one system architecture diagram. I will write a system architecture diagram. So like I have to, as part of capturing the details, first of all, I have to store the details in some database. System architect decides what SQL server I have to use. Should I go for a SQL or no SQL? Or should I go for a SQL server, Microsoft SQL server, or should I go for an Oracle, or should I go for a Postgres? So which one I have to choose? So based on the requirements, based on the development team, they have system architect will decide whether should I develop this in Java or should I develop this in Node, right? Or should I develop it in Python? What is the UI? Now in UI, should I use React or should I use Angular, right? Or should I use some other component? So these are all some of the system or architect decides based on understanding the requirements, right? And what servers I have to deploy. Everything architect, he understands the requirements and converts the requirements into system design. So when I say system design, the artifact out of this system design is a architecture diagram. That is the first and basic this thing. So as a tester, we should understand that architecture diagrams, right? So we have to, why we have to understand, so that we have to strategize. Okay, if they're using if they're in the architecture diagram, if it says, hey, we are using Oracle database, then we have to install Oracle client in our machines, right? We have to prepare for testing. So we will install Oracle client. And then if they say we are using Unix, during that time, okay, if we don't know Unix, we will prepare, telling that, okay, we will prepare our team to understand, to learn Unix while software during this implementation phase, when they're starting developing, we will prepare for what is coming for testing, right? So for those kind of a things, system design is also very, very important aspect for a software tester to understand. He need not design anything, right? Once the design is out, so it will be sent to the whole team. So we have to understand when you are working on a project, when you joined a new project, think that you went to an interview, you successfully cleared an interview. The next thing is the next thing is, if everyone wants, next important thing is what kind of questions you have to ask, right? First thing, what domain are you testing? Is it a healthcare domain or is it a retail domain? And the next thing is, what kind of, then you'll ask the questions, where is requirements? Then they will give you some Jira links. Then they will ask, where is the architecture? You have to ask, where is architecture diagram? So they will give you some link. Nowadays, now Jira, all the requirements are logged in Jira. There is a system called Confluence. Now people put all the system design in a Confluence. Confluence is also nothing but an online tool to store all the information, like to share information with the team. I can create on the fly one page in a Confluence and put some design documents in that Confluence page, and then send a mail to the team. So that's one of the this thing for system design. That's one of the artifact for the system design, right? Again, while doing the system design, not everyone will involve, but after the system design is done, then they will send this to whole, even to the product owners and developers, and also to the testers. So everybody will be part of the system design. Like everybody needs to understand the system design, right? So that's the that's how the system design takes place. And input for the system design is without requirements they can't design a system, right? So the input for the system design phase is the requirements, and the output is a architecture diagram. When I say architecture diagram, it's not just the architecture diagram, but also all the what technologies they have to use, what products they have to use. All this will be part of that architecture diagram. Any doubts?
Can we take 5 minutes break if possible?
Yeah, sure. So now it's like we will break once we next 10 minutes we will complete this, and then once we complete this, then it will be ideal to take one break.
Sure.
Thank you. Yeah, sure. It's been already more than an hour, right? Time is flying. Okay, so the next thing is implementation. So once we are done with the implementation, I will quickly cover these things before our break. Then once we come from the break, we can ask questions on this on the software development life cycle. Maybe questions part we will take after the break. Yeah. And then once the architecture diagram is in, then the next thing is implementation. This implementation phase is where the developers comes into picture, and developers will then start understanding what is the system design, and also start a requirement, and then they start doing the coding. All coding, unit testing, everything happens here in implementation phase. So once the implementation phase, the input is again the requirements and also the high-level system design that the architects does. So that will be given to the development team. So development team refers to both the requirements and also the system design to come up with a code, right? So they do the coding, right? And once they complete the coding, then they push that build to the, actually here I says deployment is after testing, but actually the deployment to the lower environments, right? This is a going live, but there will be some deployments after implementation. Before testing, they will deploy the code to some QA environment. And once they deploy the code to the QA environment, then they will send it to the tester. So there's a testing team. They'll send a mail that, hey, this is our QA environment. We have deployed the code. So start testing. So during this deployment phase, during this implementation phase, while developers are developing the code, testers will start writing the test cases. So that's where the testers will have the requirements. Testers will have the system design. So they will know during this time, parallelly, there should be one more arrow from here to testing, where once the system design is out, they can start writing the test cases, right? So that's where the tester during this phase, testers will never sit idle in the whole development life cycle. Testers will always have some kind of a work, different kinds of responsibilities at different stages, right? So during implementation phase, testers will start writing the test cases. And while testers start writing the test cases, and once the test case, they'll try to complete the test case, right? Designing the test cases by end of the implementation phase. By end of developers complete that code, they make sure that they have the test cases ready, so that once the build is ready, they start implementing these test cases over that build, right? And then once the testing is complete, once the testing team certifies everything is good, then they promote the build to the production. This is where in the deployment phase, there is a team called DevOps team, or people who does deployments or maintain the software infrastructure. Like somebody has to install SQL Server. So system architects here, they will tell, hey, we need a SQL Server, right? So system architects won't install SQL Server, right? So based on the system design, they will install, if it has SQL Server, then they will install SQL Server on the deployment machine. And then whatever software that is required for the software, they will be first install those in the machines, and then they deploy the code. Whatever the developer's code, they deploy it to the deployment environment. So that's the a job of the actual build engineer. There's somebody will say build engineer, somebody will say DevOps, right? Now there is in full stack, everyone has to do everything. That's a kind of, if you're working in a full stack as a full stack developer, you also act as a builder. You also deploy builds, right? So this is where something called Jenkins comes into picture, right? Nowadays that is also being automated, right? There's no manual things to deploy code. They push the code to deployment environment via a tool called Jenkins. So they use, if somebody asks what kind of deployment tool do you use, you can say Jenkins. We'll talk about Jenkins when we are discussing about in the technology sessions. And then once it goes to the deployment and goes to live, then it goes to the maintenance phase, right? In maintenance phase, people start using the product, and if it has any bugs, they report the bugs again in the Jira. And again, this maintenance, whatever issues comes, again they will analyze the issues, and then they go to the implementation phase. They fix those bugs, test it, and deploy. This is like a never-ending cycle. Once your application is in production, right? They either they change the requirements, or the requirements get added. Customers will ask for the new requirements. So this cycle continues. And If you're doing all this like an end-to-end, like at one stretch, if you're developing a product in one single stretch, that means you're using a waterfall model. But if you're incrementally taking few features and adding more features to it, then it is called an agile method. And in agile you have different kinds, like Kanban, Scrum. So we will discuss about Scrum in the tomorrow's session. But yeah, this is at a very high level how a software is developed in a real-time projects. In a real-time projects, what is the process of developing a software product, and what teams are involved, and how teams are involved. That's about the at a very high level. Then we will take a break now, and then we will come back, and then we can discuss about the doubts that we have, and then we can go to the next session. How long do you think is a better one to break? 10 minutes, 15 minutes?
5 to 10 minutes, brother.
10 minutes should be good. Yeah.
10 minutes. Okay. Yeah, let's try to come back by 9:40. Mine is CST time, so let's try to come back by 9:40 or 10 if you're in EST. 10:40. Okay, then. Thank you. See you in 10 minutes.
Thank you, Kiran.
Thank you. See you.
Okay.
Can we pause the recording and start again later, or do we need to continue?
Shishma?
I think he's not there. Yeah, I think so. Thank you.
Okay. So yeah, I'll also start sharing my screen. Yeah. Okay. You can start asking doubts if you have anything before we move to the next topic. But very important thing in this is you need to understand in this slide you should have a good understanding of how a software is developed, what kind of life cycle is followed, and who is involved in each life cycle, and what is the output of each life cycle. These are the three important aspects that you need to understand. So if you have any doubts, keep asking.
So Kiran, this could be a dumb question. I don't know. What is a test case?
Yeah, that's nothing dumb in this session. So that's a good question. So we will talk about all the artifacts, right? So we have a separate session here. What are the QA artifacts? What is a test case? What is a test strategy? What is a test plan? How you report bugs? So that your question, your answer to your question will come in the subsequent when you're talking about STLC. So we will talk in detail about what you do actually in testing in the coming slides.
All right. Thank you.
Actually, I was also going to ask, like, this is a software development life cycle, right? The
Correct.
whole process.
Yeah.
So we will discussing about the testing part separately. There will be a testing life cycle also, right?
Correct.
Yeah. Okay.
There are two things. Very important interview question is they will say SDLC, software development life cycle, and STLC, software testing life cycle.
Oh, okay.
So SDLC is the terminologies. They will use some interviewers use the jargons like what is SDLC. So you should be aware of the jargons as well. SDLC is software development life cycle, and TLC is software testing life cycle. And you should have a very good understanding of software SDLC, software development life cycle, before you jump into the STLC.
Sure. Thank you.
Kiran, I just want to add just one point, like whatever the phase we are going, we'll have all these BRDs and SRDs, right? So from those things, they'll get the clear picture of those things, and tester will involve in the this BRD, SRD document along with the developers, right? So that they can driven the test cases from those things.
Yeah.
As you said, they won't sit idle and.
Correct. Who is this? Kirti, right?
Yeah.
So yeah, Kirti, you bought a very good terminologies like BRD, SRD, that which we have not discussed. These are the very we should understand. One thing is nowadays, especially from last 5 years, I did not heard these BRD, SRD terms, but when like previously before from 2005 to 2013, we used to hear a lot about this BRD, SRD documents. And it is very important to understand what is a BRD and SRD, just to for everyone, like BRD is business requirement document. So and SRD is system requirement document, right? There is very subtle difference, right? One thing is here I said we collect requirements from the customers. So customers, in some cases, customers will, nowadays nobody is doing that. Customers will create a BRD document and say, this is our business requirements that we want for our product. So customer will write a BRD document, and BRD document will be taken to the a business analyst will convert or read that BRD document and convert it into an SRD, system requirement document. And then the system requirement documents will, BRDs and SRDs will be given to architects, so they will come up with system design, right? So it's important to understand this. Somebody will say, do you have a BRD or do you have a SRD? Some might ask in interviews. So still, even though nowadays nobody is following those, nobody's asking customers to give me a business requirement document, or the based on nowadays all these like Zoom calls and interviews, personal interviews, and then they record that Zoom meetings, right? They come up with meeting minutes of meetings at end of the personal meetings, and they convert those into SRDs. So nowadays we don't have that very formal way of collecting requirements. But yeah, it's always good to understand what is BRD and what is SRD.
So Kiran, I'm just curious to know, as you are saying, from the last 5 years, we didn't heard the BRD and SRD. Still, in the training, they are giving so much importance to these documents. Also, during the sign off to the stakeholders, what documents they are presenting?
When you say what documents in the which phase, are you asking in the requirement analysis?
Yes. During when we signed a contract to the customer, like this is the require. They used to note down the requirements, or like what the discussed, or what are the things they agree to do.
Correct.
Like there should be some documentation of that, right?
Yeah. So first thing is, whenever somebody, when they go, when I say bidding, right? They go for a bidding and they come up with a contract for the project. So the project contract is different from if it has an external customer like TCS, Infosys. They have these some templates for this project contracts. There is a separate teams. There will to bid for a projects in Infosys, TCS, Deloitte. For example, my wife, she works for Deloitte, and she's one time part of a bidding project. So they have a separate bidding or a template to bid. They create not just one document, like they have multiple, one PPT which talks about their company, and they will talk about, they will pitch something about their company, telling that they did these things till now. So this kind of a resume, that PPT acts like a resume for the company. Then they'll say they bid for, okay, they'll say you have these many items, so we will complete these and these many. So there is no specific these things template. It depends on the company to company, whatever the templates they have for the contracts. But the way the data is captured, important thing is what customer wants. Previously, BRDs are the document which talks about what customer wants from the product, right? So in another project which I work, they gave us, there is no document. They gave, I said it, we worked on a project where we converted one Windows application to a web application. So they gave us the Windows application full, like whoever, that is they said, this is our Windows application. There is no, it depends upon the client as well. So, how technical the client is. Some clients are not technical. Some clients says, I don't have enough time to do all the documentation. I have some point of contact in my company. If you need anything, you contact this person. Somebody will tell like that, right? So we cannot dictate customers to do something, right? So we can only say, if you want this product, we need this information, and it is up to us how do we extract information from the customer. But as I said, the only the outcome, the major outcome is the Jira. Nowadays, everything is whatever the customer wants. Business analysts will write it in the Jira. Jira is the only user stories in the Jira are the only final is considered as the final outcome of this requirement analysis phase. And previously, we used to have BRD and SRDs previously. Nowadays, these kind of Word documents are like out of like old fashioned, and nobody is using those kind of documents. Jira is the outcome nowadays. So like if you are going for an interview, if you are saying that I have 10 years experience, maybe you can tell like we used to work with BRD, SRDs, but now we move to Jira. Nowadays, all our projects are in Jira, and you can tell everything is part of Jira. All our requirements are captured in Jira. Does that answer your question?
Yeah, I think that last part totally answered my question. So we can say the Jira is a like authorization tool, and like where we can log all the requirements and everything, and one place document where everybody can come and access those who have the. Yeah, okay, that's actually really good, because it removed the burden also. Because that BRD and FRT is of course is a what you can say, like experienced, need the expertise also in that.
Correct. And it is very pain in the sense it's all Word documents. Like if you take, right, in when I say pain, if I go to an old projects like BRDs, SRDs, they used to put this in some version control systems like CVS,
Yeah.
Tata there is one Tata. So in that we have this is version control system, and in that we have multiple folders, and in each
Right.
folder we have multiple SRD, BRD documents. And it is very difficult to access those documents and properly find it. Now with Jira, it's all links and everything is in a tree structure. We will open one feature. Under that feature, we open a requirement. You can easily find that requirement.
Sure. So we can do the versioning in Jira also, right?
Yeah, you have
Okay.
versioning, everything history. You can give comments.
Okay.
So Jira is a very good tool. And see some YouTube videos on Jira. I will also share some things. I'll try to find out if I find any open source projects in Jira, which I will do that like a homework today from my side and show you something. But try to see some YouTube videos from your end. After our sessions today, tomorrow, so that get accustomed to Jira more. And
sure.
If you're starting, just go with Jira in your projects, and like in your resumes, or in your interviews, talk about I worked on Jira. We were using Jira because last 5 years, in all the different projects I worked, we always used only Jira. So there's nothing wrong, and when you say Jira, that also gives into your, that you're working on the latest technology instead of you telling BRDs as service.
Sure. Thank you so much. Thank you.
No.
Karen?
Yeah.
Can we use Confluence Wiki for our requirements? Can we say?
Who asked the question?
Shri here.
Hi, Sri. That's a very good question. That's many people has that confusion about Confluence. So there is two things. Always when there is a Jira, people also use Confluence in your projects, but Confluence is mostly used for different purpose. That's for documentation purpose. So if Jira has, as I said, right, Jira won't have system design. Like architecture diagrams will be put in Confluence. If you have any trainings, all the training materials will be put in the Confluence. So any materials like Word documents or anything will be uploaded into Confluence, and they put it in a Confluence. Or any discussions, like you had a meeting, right? If you want to create a meeting notes, you put it in the Confluence. It's not in part of Jira. Jira is only for requirements, but you should not use Confluence for requirements. So that's again killing the purpose of Jira. You cannot use because Jira is a tool to track all the how the work is being done. Right? It has a specific intention, and the tool is designed such a way to track the tasks. But Confluence is to share information in the teams. Right?
Okay.
So there is a subtle difference. Very good question. There is a subtle difference between Jira and Confluence. So Confluence is only for, like, I gave a training, you gave a training to your team, right? When you give a training, so end of the day, you put the PPT in a Confluence page and tell that, hey team, I have put my PPT in this Confluence page. Or you did some research on something, right? You, for example, I will tell my experiences where I used Jira, Confluence, and where I used Jira. For any test cases, I use Jira for updating or creating any new bugs. I used Jira, and for example, my manager called me and said, "Hey Kishore, we have to analyze an automation tools. Like till now we are using the Selenium. So I want to change. There are many new tools came into market. So can you analyze few tools and tell what is a better tool? Is it Selenium still better, or do you have anything better tool than Selenium?" So what we did, we formed one quick group of 4 people. Each one took one tool like Puppeteer, Cypress, and Protractor, and all these tools, and we validated for 1 week. and we documented all the things, whatever we find during our analysis of the other tools, we documented in the Confluence page. And then
Okay.
we documented it in a Confluence page and then shared that link to when we go to the meeting with our manager. We said, hey, we analyzed these tools. These are our findings. And we prescribed Cypress is a better tool. So we will plan to go with the Cypress. That is our findings from last 1 week of our research. And we have documented everything in the Confluence page. So we don't use, Jira is not for the documentation of these kind of purposes. That's not a end customer requirements, right? So it is internally team has some other like customer doesn't care about whether you're using Cypress, Selenium, whether you're even using automation or not. All the customer need is a a good product, a good working product, right? So anything related to the customer and executing the project is all about in Jira. They will track all that.
Okay, got it. Thank you.
So Kiran, excuse me. Yeah, you are
Saying like Confluence is more like a knowledge base, right? Suppose if anybody new, like they can go there and look for the materials, but the same access will not be given to Jira, right? I mean, like restricted access will be given to the teams alone, or
means you used a very good word called knowledge base. Yeah, so it is used for uploading documents and entering data, right? But when you come to Jira, you can only create some kind of a tickets in Jira. Like when I say tickets, it is you have to create an epic. There is always some kind of a label you have to give when you put it in Jira, right? And in Confluence, you can do any kind of documents without any label or any ticket. Right? Jira is more kind of a ticketing system, and it is not suitable for documents. So, for example, if I have to put it in Jira, this Confluence page, so I don't have an option. Either I have to create a story telling that this is an analysis of something, and I have to put everything in that story. And it is not, Jira is not referred back again and again. Once you complete something, that is done, and once you complete a task in a Jira, right? Once you complete a feature, once you complete a story, or once you complete a bug, this is closed, and it will, once you close, I don't mean you can again access them while you're opening some reports and all, but you don't keep on referring to those Jira tickets again and again. Whereas Confluence is something, if some new person joined a team, for example, we also use Confluence for orientation of any new persons. Like when some new person joins a team, we create some checklist in a Confluence telling that, hey, you need to have access to these systems, you need to install these softwares, you need to go through these product information documents, that these are the team members. All these things are like in a Confluence, we will create some checklist for new persons in the Confluence page. Like that acts as a knowledge base, so that if I find out, oh, this is this information needs to be known for any new person who joins, I will create one Confluence page, and I will link that Confluence page in that new joinees checklist, right? So that's how we use Confluence, and we don't have a proper way to use that in the Jira. It's not about having access. So certainly people will have different kinds of access in Jira. Like for example, I cannot create a requirement in Jira. That kind of access, we will block people's access at that level where only testers cannot create a requirements, or developers cannot create a requirements, and developers cannot close a bug. Developers can only fix a bug. Testers only can close a bug. So those kind of access will be given in the Jira, but creating some of the documents in Jira is not a right option.
So basic
question again. So Confluence and Jira, what are they called in the technical terminology? Like what kind of application? What do you name them?
Okay.
Like
Yeah, these are web applications. Basically,
web.
Confluence and Jira are web. It's not a you know, again there is one term called soft SaaS, software as service. So these are basically softwares. Jira, Confluence are basically softwares, right? But these softwares, you need not install anything. You can access these on web. So when you access a software without installing, you without installing anything, when you access these softwares over a website, right, on your browser, that is like software as a service. So these are available, like normally people, like there will be some technical teams in companies, they install all this at a company level. And they give you can create projects in that, like your product owner can go and create a project in a Jira. And then once you create a project, they can add members into the project. These are all on website, right? So you need not do install anything. So you can just open Jira and or open Confluence, and then we can start implementing it. Tomorrow I will try to show you this these two things, Confluence and Jira. Did that answer your question?
Yes, that's what I wanted to
know. So knowledge base, Confluence is more like a knowledge base, whereas Jira is like a work related test case formation and like the cycle that you were discussing, like product owner, testers, bug.
Basically anything that needs to be tracked up to closure is part of a Jira. Anything, so for any knowledge base is not part of any that need not to be tracked and need to be showed for completion for the project. Right? Anything that needs to be tracked so that it will affect the project timeline, those things needs to be part of the Jira so that that can be tracked to the closure. Somebody will have somebody has to be, there should be an assignee to the ticket, and that needs to be tracked to the closure. Project managers will keep tracking those tickets to make sure that the work is being done on that particular task. So anything that needs to be tracked to the closure is part of Jira. And if something is just for knowledge base and need not be tracked, those parts are like on a Confluence page.
Thank you.
The great questions. These are very important to understand these differences because these are in a real time. How do you use this? You'll be getting this real time knowledge when you ask these questions. Thanks for asking all these questions.
So Kiran, this is Soumya again. One last question. Like, as you said, you will tell tomorrow, like how to install and everything. So I was just looking side by side on the Google, like they are saying like it's free download, right? Up to 10 users, it's free. So is that so? We just have to make a login and we can start using it?
For Jira?
Yeah.
Yeah, but I don't recommend taking that route because that means you have to download. You normally won't do it in a real projects because when you go into a project, there will be somebody called an admin for that company. At company level, they will install Jira for everyone, like at a company level, and they will give you a link. But now, if you have to do it, if I don't know whether there is a link or if you have to download that Jira system software on your machines, you can do it, but I don't suggest anyone going into that route of installing everything on your machine. But to understand about Jira, you can watch few videos, or I will check if there is somebody we can access on any open source projects Jira board. So that way we need but if it is but you can try if you
no, I'm just asking a suggestion. Whatever you suggest, it's fine. It's totally fine. Yeah, thank you.
Okay. So that's we talked more about requirement analysis, Jira, and all. Any questions on system design, implementation, deployments, testing? Anyhow, we will go in depth. So in any other areas, if you have any questions, let me know before we go to the next. Okay.
Can you explain one more time about deployment in a short, like?
Yeah, sure. There are different types of deployments. One is during implementation, right? After implementation, after developer does its code, they have to deploy it before you test it. So there is a smart deployment here, but that deployment we are not calling out because it's not a production deployment, right? It is only deploying into a QA environment. So during that time, developers, or there will be a build team. Yeah, they will take this code deployment into normally people use in coding Git, right? So in the Git, people use this once they complete the code, they put all the code in the Git. And nowadays there is a tool called Jenkins. So build team, what it will do, they will trigger the build so that Jenkins will take all the code from the Git and deploy it in some machines. There will be some servers. They will deploy that code into that server and send, and then once everything is deployed properly, they will intimate the testing team, telling that the code is ready for your testing, and they give you a link. So I'm talking about web applications. So they give a build for testing. Once the testing is done, once they complete all the testing, then they will deploy it to the, once the testers certify the product is working correctly, they will deploy everything into the deployment environment, into the production environment. There is again different types, like there is a pre-production environment, like in UAT, they will deploy to the UAT, and then customers will first do some sanity testing. Once they agree, finally they will move to the production environment, right? So that's the, as part of the deployment here, there is a team, like a build team, and the deployment, that build team uses some tools. Nowadays nobody is using manually deploying. They use the tools like Jenkins. There is a Circle CI is one famous tool nowadays they're using. So Jenkins is one legacy tool, but it's very famous nowadays. Also, everyone, Jenkins is also being used in many companies. So they use this kind of a deployment automation tools to deploy your code. Basically, what it does is it connects to the source control of the code, and it gets the code from that source control and deploy it to the environment, end environment. It can be production, it can be testing, it can be anything.
Yeah, thank you. That definitely answered my question. Thank you so much.
Kiran, just one clarification. For before like deployment, and but that means for both the deployments, we use Jenkins tool, right?
Yes.
Yeah, thank you.
Yeah. And it's very, here the key takeaway is, yeah, everyone is involved in all these deployment life cycles, on all the stages of this life cycle, and each one has a different responsibility at each stage. Basically, and we have to focus on testing. So every tester should involve and know what is happening in each phase, right? And testers should, important thing is what is coming out of each phase, because testers should question if somebody gives you a build, right? You joined a team, suddenly you got one mail that, hey team, we have developed this code, you test it. This will happen in many times, and you don't have a proper requirement for that, or you don't have proper system design for that, right? So first thing you have to ask is, if you don't have requirement for that this thing, you have to question where is the requirement, or where is the system design for that, right? So if there are sometimes some features might, only might not be properly communicated to the testing team. They might be only communicated to the developers, and developers might have developed it. This happened many times, at least from my side. So suddenly we see one feature which we don't have anything. When I asked for a developer, they said, hey, this business analyst gave me this, but business analyst forgot to put tester into the loop. He only looped developers and told that, hey, develop this information, this thing, the customer asked this feature. So and suddenly in the build, we saw this extra feature. And then the first thing is, before testing it, we will stop testing there. If you find a new feature that we don't find anywhere in the requirements, we will stop testing there. And then again, we will ask, where is a requirement for this? And then if requirement is not there, then business analyst has to give some written something, a Jira ticket for that Jira ticket for the new requirement. And then we will analyze the Jira ticket, write a test case, and then start our testing. Right? So it is very important to understand whom to contact. If you don't have information, you will only understand when you understand the software development lifecycle and what is the outputs of each cycle.
So this is appropriate, like without informing the tester, the developer develop the code and the developer get the requirement directly from the business analyst. Because it can be time consuming and it can hurdle the process also, I think so.
It is in a way that's where the Scrum comes into picture. This is a good this thing is because when you are in a Scrum, when you're following a good process, these things won't happen. And the Scrum, following a Scrum will eliminate these kind of things, because there is no silos. In a Scrum, everybody is part. Like in your daily, there will be daily stand-up calls in a Scrum. So when in a stand-up calls, developer discusses what he is developing, and in that, while he is discussing, testers will be listening to it, and business analysts will be there in the call, right? And they will be, when business analysts should tell during these discuss these things in the Scrum calls. So if somebody is not discussing this in the Scrum calls and direct, that happens. Somebody will directly contact, somebody will tell something in the Scrum calls. They will directly contact developer and ask him to do this. He will do it. This might be missed in the Scrum call. That's where this might happen. These kind of things. But ideally, those things are not ideal. It's not appropriate or correct way of doing it. Ideally, when this happened, we normally say, oh, you did not tell us, we will not test. We will not tell that. We will still continue our testing, but we will ask for the requirements and then continue our testing. At the same time, we will also escalate this to our test leads or managers, telling that these things are happening in the project. We have to rectify this. In future, these things should not happen. There is a forum in Scrum, like Scrum, there is called Scrum retrospective meetings, where you can discuss all these things in the retrospective meetings, and these things should not happen in the next sprints.
I think we got a good point for the retrospective meeting.
Yeah.
Thank you.
Okay. Yeah, let's move on to the next session. Next thing is V model, right? This is very, very important, both from interview as well as IS2QB when you're doing. So we talked about, this is an extension to our SDLC, right? We talked about we said, right? I made a statement that tester is not sitting idle during these phases. He is involved in every phase, right? V model will tell how a tester should involve in each stage, right? Or what kind of, it will not talk about tester point of view. It will talk about validation or verify from what kind of testing has to happen. It will not talk about who has to test it. So for example, while you're doing a business requirements, it should have an acceptance criteria, right? So when somebody is saying, hey, I develop a shopping cart. So what is the acceptance criteria for the shopping cart? For example, acceptance, one thing is nowadays in Zira, right? That is one thing. You can even tell in your interviews that we make sure that when we are analyzing requirements in Zira, we make sure that it has acceptance criteria. So there is a section in Zira called acceptance criteria. So you can so we will make sure that business analyst or product owner who is writing that requirement should also mention what is the acceptance criteria for that requirement. That means I'll say a shopping cart is my requirement, right? But in my acceptance criteria, I will tell or payment method in the shopping cart is a feature, but one of the requirement is it should have a payment method. It should accept different payment methods. That is one of the feature. Payments is one of the feature in the shopping cart. Now, in the acceptance criteria, I will tell, hey, add the payment. I should accept Visa, Master, Discovery, American Express, right? That is my acceptance criteria. And if there is no acceptance criteria, tomorrow customer or somebody will raise a bug telling that, hey, you don't have an Apple Pay or Google Pay. So then developer will say, hey, in the business requirement, it is not there. Business requirement in acceptance criteria, it only says 4 types: Discovery, American Express, Visa, Master. So I have implemented only these payment gateways. That is why I have not implemented Apple Pay or Google Pay. So if Google Pay and Apple Pay is there as part of acceptance testing, that is because acceptance criteria is very important to understand where to close the requirement, or when we can say requirement is complete. Because I have implemented these 4, and I will say my requirement is complete based on this acceptance criteria. Otherwise, my requirement is not complete if it has Google Pay and Apple Pay, and if I have not implemented that, I cannot close that requirement. So we can only close the requirement or the ticket if that acceptance criteria is met. Right? So acceptance criteria plays a very important role, understanding and also the customers or end customers we have to be we have to validate these acceptance criteria with the end customer, so that they will accept the product. Tomorrow if end customer says, hey, why did you have not implemented, we can say, we have validated this acceptance criteria with you, that time you said only these 4, right? So that is why we have not implemented. So it is very important to get the acceptance criteria from the customer for your requirements and document it in the Jira. So during the business, so validating that acceptance criteria is very important, whether it has what is the acceptance criteria for the requirement, right? Once that is done, your next thing is system development, or it is better we go from low level. Normally we have to go from bottom to up in the V model. Actually, I started wrong from starting, but let's go from the bottom. Like, first thing is, once the coding is done, right, the next thing is, when they say coding, it is at a very unit level. So let's take the same example. Like I implementing a Visa payment gateway is one unit level. At the module level, I implement the payment gateway for all the different payments types at the module level. So that means I completed a module. At a system architecture level, I implement all these things using a proper, as I said, there will be multiple plugins. I might be using a different plugins, as prescribed plugins as mentioned in my system architecture, right? I would be using those at a system level. And then system development. So once I done this is all about integration and making the final product, like implementing this payment gateways with the actual gateways, integrating, calling their APIs, testing end to end, say saving the record in the database. That's all the end to end system development, right? And finally, giving it to the business, right? Making sure that the business requirement is met. Ideally, he should buy, he should take the data from the credit card details from the customer, process it, and successfully process the payment. That is the ideal business requirement for that one scenario, right? So these are all the different. That's how it match from the basic thing to the end user customer requirement. This V model talks about the different stages, how a product will evolve, right? And during the product evolving, what kind of the other thing will talk about what kind of at these stages, at these different stages, what kind of testing has to be implemented during coding. Once they complete the coding, that means this module, they do unit testing, right? Unit testing normally will be done always by the developer. Whoever has done the code, it is his responsibility to do unit testing. So when somebody gave me a build for system testing, right? So I will make sure that I will ask developer, hey, will you share? Most of the times there is a site where normally in Jenkins, it will execute the unit tests automatically. So testers what they will do, they will open the Jenkins build and make sure the unit tests are all passing, and it has been executed correctly or not. Right? So we will make sure that the developers are writing the unit tests and executing them before they give it to the unit test, before they give it to the end system, or for the integration or the system testing, right? So that's where unit testing comes into picture. And integration testing is also mostly done by the developers, right? So at this time, what they does is, during the integration testing, they make sure they call proper APIs. This unit testing is all about, they don't call the real APIs. They only use in unit testing, they use the dummy test data or dummy data to perform testing. Whereas in integration testing, what they does is they does the actual they call the proper APIs, or they call proper external systems like databases, and they integrate with their code to the existing APIs of the databases. So that's where the integration testing is done, and this is mostly will be done by developers only. And once the integration is done, they will promote everything to the QA, and then actually the system testing comes into the picture. And in the system testing, that's where the tester comes, and they talk about they execute the test cases, right? And once the test cases are executed, everything is done, they promote the build to UAT. In UAT, that's where the business comes into picture, and then they validate based on their acceptance test criteria. Business will say, we accept these requirements only if this criteria is met. So they only test those things. So the major difference between acceptance testing and system testing is, in a system testing, you test thoroughly end to end with all positive, negative scenarios, positive scenarios. You try to break the system, right? You test everything in system testing, like you do all your performance tests, everything in here. You don't do that business or customer or end customer they don't do all those things. They make sure that all the positive scenarios are working, nothing is breaking at a very high level, right? And they don't spend that much time as like we might spend 2 weeks for testing a product, and business will spend only like 1 day, 2 days. They test it and then they accept the product if everything is working during that. So that's the at a very high level the stages. So V model, when somebody says V model talks about what kind of validation or what kind of testing is performed at different stages of the SDLC, right? That's the basic thing of V model. And there is two things. There is verification and validation. That's what we'll cover next in detail. We need to understand as a very important question from IS2QB point of view, but also from interviews, if they want to check the exact whether you have the correct process knowledge or not. This is very important, is what is the difference between verification and validation, right? One very high level verification is all whatever you do manually in these things, right? So in this V model, all what kind of validations you do internally during business requirements. You do some verifications. You don't validate, because business requirement is a document that you verify, whereas code is something that you validate, right? Code is it performs coding. When you do your application performs something, your code takes inputs and it performs something and gives some output. So that is a validation. So anything which involves some working stuff like code or the product, when you test that, it is called validation. Anything you do, like you review a code, a developer, normally as part of my role as a dev lead, whatever my developers does, I review them. I see their code. I don't even execute them. I see whether they're following the coding standards, whether they're following the correct naming conventions, right? Whether are they following proper, if they're exiting the loops correctly or not, right? So I validate those things just by looking at the code, right? I need not even execute code. When I'm executing, that is validation. If I'm just looking at the code and I put some comments, say I don't accept this code, you have to modify this code, that means I'm verifying their code. That's like process of verification, right? And there is also a subtle difference between QA and QC, right? So whatever you do in the testing phase here is all about QC, quality control. And whatever testing you do or whatever validations that you do or verifications that you do is all about quality assurance, right? There is also a separate, I have put a slide. It is very important to know what is difference between quality assurance and quality control. It is very important to know what is difference between verification and validation. We will talk about that now, but before that, any doubts on this V model?
So this is Soumya. Just wanted to make sure like quality assurance and quality control both are done by the QA only, right?
Yeah, good question. No, so it is not done by QA alone. So for example, right, quality assurance is not just QA's job. Quality assurance is everyone's job.
Okay.
And for that matter, quality control is also not every QA's just tester's job, developer's job as well. When he is doing unit testing, he is doing quality control, right? And testers won't do unit testing. Developers do unit testing. So developer is doing a quality control. And when a developer is doing integration testing, he is doing quality control. And when a system testing phase, this is the tester comes into picture, and he is doing a quality control, right? But there is a very misconception, or in teams they say this is QA team, right? When they say QA team, but QA team means they have only system testing in the company, like, but actually from ISTQB point of view, or actual, if you take the quality assurance, the terminology of, or the meaning of the quality assurance, it is everyone's job, not just QS job.
So we can divide like this, like two type of testing, like static testing or dynamic, right?
Yeah.
Inside the dynamic testing, we can further divide one done by the QA and another one done by the developer team. It's like
No. Again, yeah. This is like, all these are like good questions, because these are very confusing topics from process point of view. So again, static and dynamic testing. You brought a very good this thing. Yeah, verification is a static process, and validation is a dynamic process. So right, again, this diagram should give you or answer your question, because in this diagram, all this process, any validation, anything done on this is a verification or static. And static thing is done by, like here what I said, as a developer lead, I will verify my code, my developer's code, before I check in or accept the code. So that means a development lead is doing verification, not a tester.
okay.
So development lead is doing static testing on the code that is developed by his team. Right?
Sure.
And
Yeah.
when the system, for example, there is one architect in my team. He creates an architecture diagram, and that architecture diagram, he will get it validated by his senior architect from a different project, right? And he will verify and validate that, okay, whatever you done is correct. And then he will, because he is not there, there will be some kind of verification has to happen in every stage, right? Nobody's work cannot be goes to the next stage without verifying. So that means another architect is verifying another architect's work is a static process, right? And that is also called as a verification, where architect is doing it.
Okay.
So that is also a static analysis or static process, and it is done by an architect and not the tester. So this V model is not about only for testers. In a project, what kind of testing will happen, irrespective of our testing team, what kind of testing will happen? That testing can be done by anyone. Unit testing is done by developer, and here system testing is done by tester. And here mostly verification is done by not a tester. It will be done by developers, system architects, business analysts. Maybe here verifying the business requirements can be done by tester as well. Does that understand? Did you get it, or did I confuse you?
I think like this validation part, we can divide this testing thing into another part. Can be divided, like I feel like white box testing, or from the development point of view. I mean the developer point of view, or what that QA do. Another one, white box.
Black box testing.
Black box testing, yeah.
So I covered that, like what is the testing techniques and types and levels of,
Okay.
right? So this testing techniques and types of levels of testing is very important when you to identify in the V model. So when you are doing some testing here, what kind of technique you are using, that's where the black box testing comes into picture. And when you are doing integration and unit testing, that you do white box testing.
Okay.
Yeah.
Okay.
So when we are talking about now, previously when you asked who is testing, so the who part is anyone. It's not. We should not be under an impression that only tester does validation or only tester does QA. From
Okay. Okay.
who perspective, we are talking about testers. Anyone like, or there is a proper in only developers does validation in this stage, architects does validation in this stage, testers does validation in this stage, analysts, business analysts does validation. Sometimes even testers also can do validation in this stage. The who part, but the other question is, okay, when you are doing these kind of testing, how are you doing this system testing? When you tell how part, that's where the black box testing. Now here, yeah, how are they doing unit testing? Using white box techniques.
Yeah.
How are they doing black box test? How are they doing system testing? Using white box testing technique, black
box.
Right. So the how part we will cover
Okay.
in the later sessions when we are discussing about the testing techniques, types, the levels of testing. Now we are talking about levels. So when we are talking about V model talks about the level of testing.
Okay. Okay. Maybe I got confused with two, but I think I am fine now.
Yeah, it is very normal to get confused between these because there are so many terminologies, very confusing. Everything seems very similar. So the like in my starting of the career, I also have the same confusion. Like I keep getting confused between a lot of these terminologies. It took at least for me like 5 to 6 years to understand. Till I wrote. I started my career in 2006, and I start in IT, and I gave a ISTQB in 2009. So till I gave my ISTQB certification, only then I came to know these. I cleared these confusion. Like I got my confusions cleared. So yeah, it's very otherwise till then it is like, somebody will use verification, with somebody use validation, somebody will use quality assurance, somebody will use quality control terms. So it's very confusing, but yeah, nothing to be confused. That's a very common thing initially. Yeah, but yeah, if you follow, that's why I have divided this PPT such a way that you understand all these things clearly.
Hey Kiran, in this V model, is the verification and validation are done parallelly?
Yeah, or means when we say parallelly, ideally, once the verification is done, then they do validation. For example, right? I cannot very tricky question in a way, not to confuse more. You can think this can be done like, first you verify, and then you do validation. For example, you do verification of your code, right? So a developer lead has to verify the code, and once he verifies the code, only then it gets deployed to the end environment and in a testing environment to get it tested. That means they have to do validation, right? So that, whereas somebody can keep verifying the code and parallelly while I am for example, this happens regularly. I keep telling my team, hey, whenever you complete some piece of code, send it for me to verifying it. Don't keep the code at your end for a long time, right? So what my team member does, once he wrote some like 100 lines of code, before he starts writing unit tests, he will send the code to me. I keep verifying manually. Like I do my verification code review. while I'm doing my code review, he writes his unit tests. So that means verification and validation here is happening parallelly, right? So that depends upon the instance. Like but this code review is mandatory, or it cannot happen parallelly with system testing. Some things can happen parallelly, and some things cannot happen in a parallel. Like that means if code review is happening parallelly with system testing, that is a wrong thing. Like you are not following the correct process, because I cannot without me certifying the code. Like as a developer lead has to certify the code before it is sent to the system testing, right? So
Okay, thank you.
yeah. So there is no certain rule that it has to happen parallel, one after another. So this is because verification is a very vast. It covers all these things, so that it cannot happen. We cannot say verification has to happen before validation, or validation has to happen after verification. There is no set rules there. It's very difficult to tell that.
Yeah, Mr. Kiran, like in verification, there is some techniques, right? Verification comes under like review and walkthrough and inspection.
Right.
So in verification, we'll be only more focusing on documentation, right?
Yeah, when I say documentation, it is more focused on the, for example, code is not a document, but it's a written something on a no, code is also it's written in English, right? So but it is not, we will not call code as a document. So codes, yeah, it is part of like code and documents. When you verify a document or when you verify a code, basically now there is no documents, it's all Zira, right? So when you verify some requirements in Zira, right, and when you verify some system architecture in Confluence page, so these are all verification. It will be done on a artifact. Basically, we call it as an artifact. Artifact can be any type. It can be a document, code, or a web link. So whatever artifact you are working, if that artifact you are statically doing again there is a how part. When we say how are you verifying,
Yeah.
the how part will answer these questions. I have put that in inspections, reviews, walkthroughs are different ways of doing verification.
Yeah, got it. Thank you.
Hi, Kiran, this is Nancy. Can you give us any example about this V model?
That's the, yeah, I while I'm explaining, I talked about coding, right? I develop, so here developer code does coding, and once the developer is done coding, he writes his unit tests, right? And once he writes the unit tests, here parallelly a developer lead will verify manually that whether his code is correct or not by just looking at the code he wrote. And then here system architecture, in system architecture it says you have to connect to some APIs, right? These external APIs, or you have to implement the some modules or some plugins. So those things, even here, while developer lead is validating the code, he will make sure whether this developer is following the system architecture, and that is one of the static analysis he does. And here in the verification, I said like system analyst will share his system architecture to another senior architect, and he get it validated there. So that is one. In system development is where the actual system tester comes into picture for testing these things. And here business analyst will come into picture. His team validates his, or sometimes tester does. So that's about this. I'm not sure what did that answer, or anything that you're expecting.
Yeah, I got it. Thank you.
Okay. then if you're all clear, we will move to verification and validation. So I think we covered a lot of ground on verification validation here. If you see here, it evaluates the intermediary products to check whether it meets the specified requirements at a particular phase. So each and every phase has a specific requirement. So coding a unit, this is at this phase is all about a particular module or particular unit of development. At this phase is more about integrating all these modules into one single system, right? And again, this phase and this phase is almost like a similar when we talk from the developer's point of view, where it is more about system like integrating multiple modules to a single system so that it acts as a one end-to-end system, so that we can do some system testing on the end product, right? So each and everything has a particular specific requirements for each phase has a specific requirement, and each has some intermediary product. Each phase of this will have some products coming out of each phase, and that's where it evaluates this particular intermediate products, right? And validation, it says you evaluate the final product to check. So again, this final, there is again a subtle difference, because every phase will also have a final product, right? Unit testing has a final product, that code, that is also, so that is a validation. So and also and that is why we need not focus more on intermediate or final. Basically, whatever the final product of this particular phase, right? And mostly it focuses on the static and dynamic techniques. The way you test identifies whether you're doing verification or validation. If you're doing any static things, it's all about verification. If you do anything validation, it is all about dynamic. If you do dynamic, it's all about validation. This is also important. You don't do anything with software in verification. This is done without executing the software, right? That's what, again, static. When we say static, it is that. So it is done with executing the software. So you use validation when you run automation scripts. It is using the automation software to execute that, to do your validation. So that is dynamic. Even when you're doing manually, you click those buttons, right? You click the buttons and execute that code. When you click the button in the back end, the code gets executed. So it is also basically executing the software. So that is validation. And again, there are different types of verification. As I said, review code, we do code reviews, right? Those are there are different formal and informal types of verification are there. Reviews, walkthroughs are very informal. So I go to my colleague's desk and asks him, hey, can you walk me through your code? That's a informal. And when I go to when I do, sometimes it can be very formal. I'll create one meeting, and I'll ask, there is a formal inspection. This can be, nowadays nobody is doing these inspections. If a team, normally when this comes into picture, right, in a real time, if a company is going for a ISTQB certified, you would have seen some companies they will say we are ISTQB 2001 certified company, or ISTQB 9000 2000 certified company. So these kind of company, when you say this, that means they have to follow some processes, right? During those times, this they have to show that we do inspections, walkthroughs, we do these kind of techniques for this. So that's where they create these kind of documents for inspections, reviews, and all. Otherwise, nowadays most common thing is reviews, and walkthroughs are very common, right? So and another important thing is this thing. There is a very subtle difference between, are we building the product right? That verification's main goal is not about the right product. Means, see, right product is, I think we have seen this diagram, right? So verification doesn't make sure that you're meeting the customer's product or not. All it does is, are you following the right process, right? So for example, here I will say, are you what I gave an example, right? I will verify whether you gave a correct naming conventions, or you gave the correct no coding standards, and whether you followed if you are exiting the loops, if loops and all properly or not. So some code can be very perfect. They can follow all the proper guidelines, but still they can develop a wrong product, right? So I can follow, I am developing this, my developer might have developed this product, but while developing this product, he might have used the correct naming conventions, correct coding standards, but he developed a wrong product, right? So verification doesn't check whether you're building the right product. It checks whether you're building the product right. There is a very, very subtle difference. Don't get confused. So when I say product right, you're following the correct process. And validation checks whether are you building the right product. That is where you check whether what is the customer wants, whether whatever customer wants, whether are you building that payment, whether is your payment system is taking your credit card correctly, or is it connecting to the right APIs. If you put a Visa card, it has to connect to a Visa API. It should not connect to a MasterCard API. So those things, it has to check whether you're building your right product or not, is actually the validation, right? Even this is also checks whether the product is built as per the specified requirement and design specification. This is more about process oriented. This is about the fit. Like it will talk about, okay, you have built a right product correctly, but is it fit to use or not? Is it what actually the customer wants, right? So whether is it satisfying this business needs is more about validation. Are you clear?
So in this, I don't know, when the BA make any documents or like create any requirement in Jira, so that document represent like requirement can be represented by the pictures also, like we use the wireframes, prototyping and mock. So that thing won't show like what features they are exactly asking, and that helps the developer to build the right. Oh, okay. I think we are talking about the functionality here, right?
Yeah. Well, it is not that. That will definitely help, but the intention of verification here is to verify whether he's following the right process.
Okay. Process.
Right? So yeah, definitely that wireframes, everything for example, when you are verifying the business requirements here, when that itself is, if you in a way you are, when you do your business requirements verification, in a way you are also thinking that you are evaluating whether the business requirement is fit for use or not here only.
Okay.
When somebody verifies this business requirements, that means that whatever the customer asks, whether is it correctly, means the customer will tell me one thing, I will write that into a document, and I will again send the document back to the customer and ask that, hey, we have documented this, is it correct or not, is it what you really want. If a customer validates the document, and says, okay, yeah, this is good. This is what exactly I want. That means customer is verifying, doing a static analysis, and he's verifying and giving it back to the business analyst. So in a way, you are going in a right way, and you're in a right product only. But that is this is about process, more about whether are you following the correct process or not. So that it is quality assurance is where people will say, yeah, this is more when I talk about quality assurance and QC, we will talk, but this is more about whether you're following the process, you sending the document to the customer and getting an acknowledgement from the customer that this is correct is also one way step towards the correct product.
So, Kiran, I have a question. So, in the verification and the validation, if you will take these two, while you are doing the verification, you and your stakeholder, customer, are discussing whether it will be customer friendly or user friendly or not. Everything will be discussed in the verification, okay? But when it comes to the validation, the same verified product, is it working properly or not, you will validate with the real data.
Real product, because during that time, in the first scenario, there is no product. You are validating everything on
paper.
On paper, right? So that is
documents
there. So that is where you cannot implement all kinds of validation techniques on that product. When you implement these inspection reviews or walkthroughs, you are reviewing your document. You cannot do functional testing on that document.
So live example, suppose take a Capital One card. If they come to you for coding, they will have 4 different or 6 different like savings or recurring deposits or home loan, car loan, something different modules they have. Okay, they'll come and discuss with you. The first thing is they will come and tell you, I have suppose 1,000 customers, they want to do some financial access. So when you start, because you started in the V model with coding, okay, let's take, you will talk to them and say like, first I will start coding for a customer savings account. Like that, you take a small module in that and you start developing the code, right, sir?
Correct.
So when you are discussing with your stakeholders and as well as a product owner, you all sit and there, what is the most information you need? Their name, their numbers, dates, balance, what debit card, credit card details and all, you will put it in that code, right, sir?
Correct, exactly.
So parallelly, what the particular validation team does is like whether the system is what could be the validation, like whether the code is taking the name.
In that verification, you say what kind of code, what you have to put, like what kind of details you have to enter. That will actually enter and validate.
Okay.
So they do it practically. This is more about practicals, more about documentation.
So another like test conditions and all like comes under where we see like test procedures, load test, stress test and all comes under validations, right?
Exactly.
Oh, okay, sir. Thank you. Got it. Yeah.
But there is a very, people will take verification very lightly and they more concentrate on validation. But anything identified in verification is very, very important, and it is very less costly to rectify identifying in a verification process. For example, if you identified some bug telling that, hey, you missed something, some kind of a you missed a requirement that your CVV has to accept 4 digits. For example, American Express will have a 4-digit CVV, but somewhere in your requirement you said CVV is just a 3-digit number, right? If you have missed that in verification, if somebody is verifying and did not find that and was given for a developer to develop, and if he just developed with 3-digit number, you might eventually find out that bug in validation, telling that while you're doing validation, you might enter American Express card, and if you're not able to enter the 4th digit of American Express card, here tester will definitely raise one bug. But
yeah, okay. Sorry to stop.
Yeah.
Yeah, sorry, go ahead. Sorry.
So definitely QA will raise a bug and the developer will come again and fix it. But what if it was find out in verification? You are saving so many hours of developers and so many hours of testers, because when you find a bug, it takes a lot of time for tester to enter all the details in a bug detail, and again he has to send it to so everything, lot of hours, you spend a lot of hours, and the hours you spend is equal to the amount. So fixing a bug at a validation is more costlier than fixing a bug in verification.
Right. So, sir, Soumya, I think asking the previous question, when you enter this verification documentation and these diagrams and everything, so these details, will it be shared with the validation team as well? Because they should know, right?
Sorry, can you come again?
See, in the verification, whatever the documentation or the flow charts or the diagrams, the architecture, so all these things, these documentations should be shared with the validation team as well, right?
When I say it is not, for example, as a tester, it is very important to understand what is the requirement. So definitely requirements and all has to be shared. But these things will not normally, for example, code review comments. So it is not very important from a tester's point of view to, like, for example, I gave change this code variable from camel case to a snake case. If I give this comment to a developer, he will fix it. But tester need not know this verification comment that I gave, because it's not very important from the testing point of view. From the testers, they need to identify whether the application is working correctly. Right?
Okay, sir.
So from verification detail, output of the verification comments, whatever I give in my review comments or walkthroughs, normally this will be, in an ideal way, is accessible to anyone in the system. If I give a comment to a developer's code, other developer it is accessible to other developers, but it is not their duty or job to verify and do. It is up to them to whether they can, out of interest, they can go and look.
Okay, so sir, who will decide like till what information or what requirements the validation team needs, and which database or which application will hold this information? Like I think Soumya was asking, do they use Jira or something to store these documents?
From verification, right? So for example, normally if everything like zero, if I am verifying my code, for example, if I verify my team member's code, it will be logged in Git. Normally nowadays everyone are using Git. So everything will be logged in the Git, all the review details of my code, right? If I'm reviewing some Jira ticket, it will be there in the history comments. I can give you my comments and it will be there in the comments. So basic Confluence, you can have discussions on the Confluence. Nowadays, these are the important tools which developers or testers will regularly follow. Like one thing is Git for code, understanding. Testers will, some testers will go one level deeper and try to understand how the developer has coded, right? Nobody is stopping testers not to see developers code. All testers, for example, in my team, now my team has is a full scale or full stack developers. But previously, when we are working in a separate team with a separate testing team, all the testing team members has access to the Git, where we can all see what developers code is. Nobody tells why do you need code access. Nobody will talk. Everyone, it is important that testers has access to code, but some testers will go one level deeper and try to understand how that is being coded. not very detailed way. For example, what are the important things, what technology they used, how they are connecting to databases. They will try to find out from the code itself by reading the code. But it is not mandatory to do that. We can stick to just black box testing techniques and implement all the black box testing techniques that we know once we have the product out, and we can continue like test that.
Okay, thank you, sir.
I think we crossed our time limit for a quick time check. I will stop here. Basically, going good. The agenda, I thought of completing this, but we discussed a lot about QA, QC as well. Tomorrow, when we continue, I'll continue from here. And basically, there is no, basically this takes, yeah, this is the basics of everything, whatever we do in all the sessions. This is the basic. These concepts are very, very basic concepts and very important to know. So yeah, that's why it is okay to take some time to understand these things. So definitely we are mostly on time or on track. Only thing we could not cover this, but I will cover this tomorrow and try to cover the other aspects as well. But yeah, if anybody wants to drop off, can drop off. If I can spend some more time, I will be here for next 15 minutes. If you still have any doubts, I'm okay to clarify the doubts more.
Is it possible to share the PPT in advance because it will help us to?
Sure.
Because I feel comfortable because whatever you are saying, I can write parallelly on that.
Correct.
And some key points we can miss during the training, but if you can share in advance, it will be really helpful.
Yeah.
We'll
Sure.
appreciate that.
If I have some PPTs available before, I'll definitely. This is something which I prepared by yesterday. Till yesterday, I'm working on this PPT. So
Okay, no problem.
if I prepare something beforehand, definitely I will share it. I'll share it to Ravi. Ravi will share it to everyone.
Sure. So one last thing, like the purpose of doing all this verification and this validation basically is to remove the error as much as possible, find the defects so that it can be time saving and cost effective, and it can increase the quality of the software.
Exactly. Yeah.
Okay. Very good session. I really like the doubts you cleared, the way you explain, and everything is in so much in detail. And I really appreciate your patience to bear us.
No
Thank
problem.
you so much. Thank you.
No
I think
problem.
that is the quality of the tester, right?
To have patience.
Lot of patience.
Patience is very important.
We are learning this. I'm learning this from you.
Yeah.
But
Thank you,
great
Mr.
questions.
Kiran.
Like this is really, when you ask questions, that also gives me some confidence that whatever I'm telling that you're able to understand. So great questions. Even some of the questions you asked might clear other people's doubts. So they might also have a similar doubt, but they might not get that question. But yeah, great questions as well. Keep asking these questions in these sessions. No problem if we can, as I said, I can extend for like a couple of minutes in this session, or we can have a separate another session as well. So, but it is very important to understand before we go to any new topics.
Yeah, and Kiran, like one more thing, if I feel like if you feel that whatever questions we are asking, you might be covering in next slides, and it's okay to say that we will cover this in the next slide because we don't know, right? You are expert,
Yeah.
you can tell us.
Yeah, I will. But yeah, if I feel that it is okay to, I will touch base. If it is okay to touch base there, I will touch base there. Otherwise, yeah, I will go to the next. But yeah, these are very, very basics and very important. We should be very strong on basics. It is okay to, advanced concepts we can skip. It is okay to skip advanced concepts, but these basics are very, very important, and we should once, if you're strong on basics, it is easy to build upon and easily understand the advanced topics. So that's why spending so much time on these basic things, and we'll keep spending time on basics, and it is okay to skip some advanced things. But yeah, it's very important for understanding the basics well.
Hi Kiranji, this is Leena. I just have one quick question about the verification and validation.
Yeah.
So as a tester, validation is an important part. Is it right?
Yeah. As a tester, you spend a lot of time on validation, right? You spend a lot of time on validation, but you also do verification. For example, you if you're a test lead, right? What you do, you verify your team members' test cases. So that means that is a verification. So for a test lead, you verify, like how developer lead verifies his team member's code, you verify your tester's code, testers test cases. So that is a verification. So you also spend time on verifying. You verify business requirements. So whether sometimes some business requirements might not make sense, or sometimes it is very difficult to for testers cannot test that requirement. For example, if you take this payment gateway of MasterCard, sometimes you cannot do it in a test environment. So you have to verify the requirement and see whether can you test this requirement in testing environment or not. There will be many cases in real-time projects where you won't be able to test some things in testing environment. You have to either do some kind of ask developers to do some kind of tweaks so that you can test it with some dummy data. For example, payment gateways. In testing, normally what we do, we have some for each payment gateway, we have some dummy accounts with a real payment gateways. In some things, we will say in testing, in a lower environments, we will only test using some dummy code with dummy. We will not even touch the main MasterCard and everything's payment gateways. We will test it with a with dummy code. So means to come up with that kind of strategy, you need to review the business requirement, and you have to form kind of a test strategy of whether you can test whether this requirement is testable or not, right? So those are the things that you have to review. You review this from your testing point of view. You will not question the customer's requirement. You will question whether means you will review or verify this document so that you business requirement, so that you formulate how to test whether it is a testable, whether the requirement is testable or not. So those are some of the things, verifications that you do on the requirements or on the test cases. Somebody will test. There is test manager. Test manager reviews the test plan developed by test lead, right? So that's where verification is basically done by tester, but his majority 80% of job is validation, and in that validation he's into system validation.
Okay, got it. Thank you.
One more thing, Kiran. We have a slide for the differences between verification and validation, right? So you said this is important from the interview point of view as well. So now, for example, considering myself, I do not have any real-time experience or anything. So of course, I did understand the basics of this. So so when they ask me in an interview anything about this, so there are chances that I might not, get it into my mind immediately. So do you think it will help if I kind of by heart this one, or it's not needed?
Yeah, it's a very valid question. You can definitely understand it. Even by hearting is also next thing. First, if you understand when you go for an interview, so yeah, you should have this. I have put this next 2 sessions, like almost tomorrow's session. we will complete all this process oriented stuff, like all these processes. And this is very simple document of 20, even there is 20 slides, but the real content of this is very less content. So it is okay even to by heart also, because these are the basics. It should always be there at your fingertips, right? There is nothing wrong about by hearting it, but and it is I have given such a way that it is easy to by heart as well as it is easy to understand.
Understand, yeah.
So if you see any software testing real books, there will be some big 200 pages, 300 pages document. Even IS2QB also very big, 100 pages PDF is there. I think I have shared one link here. This IS2QB document, the foundation. So there is a PDF there. But yeah, what I would suggest is whatever these 20 slides you have is more relevant for your day-to-day activities, clearing an interview, and even to an extent going to an IS2QB certification, right? So this is very important. Over it, you feel free to gather more information from the any other sources. But this is the very basic and must have.
Thank you. And thank you so much, Kiran. That was really helpful, and you explained it so nicely, and thank you for your time and patience. Yeah.
No problem.
So as you mentioned,
10 more
sorry.
minutes. I'm just giving a update. I will stay for 10 more minutes. If anyone wants to drop, can drop off. You can ask, continue asking questions as well.
Yeah, one more question about the interview. I am also new to this everything because I am not from IT field. So in interview, are they going to ask like explain me to verification method like that, or there will be tricky questions?
There won't be any tricky questions from, at least from till now. Whatever we discussed, they will ask. They will ask what is your process, and they will ask how is your process in your project. Then you can tell about, yeah, this is our software development lifecycle process. We follow. We will go talk about Scrum in the next session. Ideally, if you are new to the project, I would suggest. I will give you some tips like today what I told, like Jira. Go with Jira by default. Anybody when you are putting a new project in your thing, if you don't have previous experience, start with Jira and Confluence. Jira. Today we talked about 3 tools: Jira, Confluence, Git. Right. Tomorrow I will show you those tools. Try to show you those tools, and just put those tools and be confident on those tools, and talk about this process with those tools. Requirement analysis, Jira; system design, Confluence; implementation, Git; and again testing also it's part of Jira, right? And deployments, we talked about a tool called Jenkins, right? So
yes.
So just talk about those tools you need. Otherwise, there are so many tools, and some are like, so for example, we talked about BRD, SRD. Those are like outdated. Now we need not concentrate on those unless until if you put some 15 years experience, maybe they will ask. Maybe if you keep like 4 years experience, they won't. It is okay if you don't even know BRD, SRDs, but it is not okay if you don't know what is Jira. It is not okay if you don't know what is Git, right? So those are red flags in an interview. If you don't say, I don't know about Jira, I don't know about Git, those are big red flags, right? So that's very important. So similarly, I'll also give you, like, we should, if you're talking about for the first time, we will talk about Scrum process. So everyone this is basic. Everyone are using Scrum. So it is a big red flag that if you don't know what is Scrum, That means they can identify you're not a real project candidate with a real-time project. So that is why we will talk about how do we what is a red flags in interview, what you cannot miss. So basically that's why whatever I kept here in this, if you are as I said, like you can by heart even these things easy, and try to understand. First of all, try to understand fully, and then try to by heart it, so that it is very basic. Then you will get a confidence. Basically in interviews, it's all about confidence. You have to talk about, even if you did not do, if you understand thing, you can talk confidently, right? So try to understand this, and then you can easily grasp. Even if they do a small twist also, you can easily find out and try to answer correctly.
Okay.
But yeah, as I said, we will also train from interviews perspective. So everywhere I'll try to stress on how do we attend an interview as well, because that's the ultimate goal, right? Training and learning is one aspect, and also clearing an interview is really the ultimate goal of this training. Okay.
Hi, Mr. Kiran. This is Sushmita.
Yeah.
So apart from this PPT, do we get any manual workbook kind of thing that has the detailed explanation of the models?
With the PPT, you get a recording, so anytime you can play back this recording. And I given this web resources, right? So end of the PPT, you will always find something. If you are more interested on some things, I'll keep adding on to these things, because I gave one free course for Java. So I even gave some paid good courses in Udemy. Sometimes you get for $10 some courses. Only thing is, with the paid, what is the problem? Why I will not suggest these kind of paid courses right upfront is, these paid courses for software testing itself, there will be 40 hours training.
Okay.
Right? You have to spend 40 hours. So to understand, because these kind of one-to-one interactions, or this is more, I and Ravi sat together and understood what are your end customer requirement. Like for example, who is our majority of them are not in IT or new to IT. So how to effectively tell, so that you understand better. Otherwise, if you just give this $10 course to you and 40 hours, it's not really effective for you to go. All these things, whatever we discussed, can be covered like in a 40-hour session.
Okay, that's right.
So now if you listen to these sessions, then you take one paid course with $10, then you need not even go and spend 40 hours. You know where you are not strong on. Maybe you can go and even after all these discussions, it is okay if you don't understand something, verification, validation. You will go take one course where you have that verification, validation. You keep repeatedly hearing those, or sometimes I might not cover everything there. They might have 2-3 extra points there that you get from these courses.
Okay, it's like a backup.
Yeah,
right?
backup. But whatever we are covering is like vital, very important, must-have things.
Okay.
Yeah.
Okay, sounds good. Thank you.
Okay, I'll be there for 5 more minutes, then we'll stop. Now I'll stop the recording.